Hello beta, good evening everyone. Today we will be going ahead and we will be discussing number 1, random variable. ठीक है. Number 2, probability distributions of random variable. एक दो बहुत important and common questions हैं that I will be discussing with you. Number 3, we will be talking about different kind of discrete probability distribution functions. जैसे हम बात करेंगे पॉइजन, बाइनोमियल, हाँ. सो उनके जो भी इंपॉर्टेंट एस्पेक्ट्स हैं. एनीवेज द लेक्चर इज अवेलेबल बेटा. अगर आपको पूरा देखना है यू कैन गो बैक टू द स्टार्ट्स वीडियोस एंड डू इट. बट वॉट एवर विल बी द इम्पॉर्टेंट पार्ट्स जो मुझे लगता है कि चांसेस ज्यादा हैं उनके एग्जाम में आने के लिए, आई विल गो अहेड एंड आई विल डिस्कस दोज पार्ट्स विद यू टुडे. सो to begin with, let us start by understanding what is a random variable. Any variable, देखो definition में ही है what is a random variable. So any variable which is random in nature. Random in nature in the sense that any variable which can take different values, that becomes a random variable. एक बहुत important और basic हाँ एग्जाम्पल रैंडम वेरिएबल का होता है when we toss a coin. तो अगर जैसे हम suppose I tell you that you're tossing a coin once, हाँ, तो there are two things that can happen. Either you can get head or you can get tail. तो we want to go ahead and we want to convert this into a random variable. हमें इसको random variable में convert करना है. और इसको रैंडम वेरिएबल में कन्वर्ट करने के लिए व्हाट वी कैन गो अहेड एंड डू इज दैट वी कैन से कि लेट एक्स बी अ रैंडम वेरिएबल और लेट एक्स रिप्रेजेंट द नंबर ऑफ हेड्स व्हेन कॉइन इज टॉस्ड. तो अब क्या हुआ, या अगर टेल आएगा तो नंबर ऑफ हेड विल बी 0 और अगर हेड आएगा तो नंबर ऑफ हेड विल बी 1. So what we have done is we have converted this. ये जो भी हमारे पास यहाँ पर था, we have gone ahead and we have converted this into a random variable. हमने इसको एक random variable में convert कर दिया, right? So this is the first thing बेटा. Similarly, जैसे अगर मैं आपको बोल दूं that x represents the number of heads when coin is tossed twice. तो अब हमें पता है कि if I am tossing a coin twice, तो क्या आउटकम हो सकते हैं? What can be our sample space? I can get 2 heads, first head, second tail, first tail, second head, and दोनों tails. This will be my sample space. ये मेरी sample space हो गई है. तो एक बार ही मुझे मेरी sample space मिल जाए. क्वेश्चन बोल रहा है number of heads. तो बेटा नंबर ऑफ हेड्स कैन बी 2. यहां पर नंबर ऑफ हेड्स 2 आ रहे हैं. नंबर ऑफ हेड्स कैन बी 1. ये देखो इन दो केसेस में नंबर ऑफ हेड्स आर 1 एंड नंबर ऑफ हेड्स कैन बी 0. ये देखो यहाँ पे दोनों टेल्स आ रही हैं, सो हेड्स आर 0. सो आई हैव गॉन अहेड एंड आई हैव कन्वर्टेड दिस इनटू अ रैंडम वेरिएबल. अब ये जो था ये स्टेट, now I have converted this into random variable कि number of x's can be 0, 1 और 2. ठीक है. तो what is a random variable? क्या है फिर एक random variable? जब भी whenever you go ahead and you take the sample space. हमारी sample space ये थी HH, HT, TH, TT. When we go ahead and we convert that sample space in the form of a variable, जब उसको हम कुछ numbers दे देते हैं, उसको हम एक variable का form दे देते हैं, that is called as a random variable. Now this random variable, it can be either discrete beta or this random variable can be continuous. या ये random variable discrete होगा या ये continuous होगा. तो जब हम discrete random variable की बात करते हैं, when we talk about discrete random variable, इसका एग्जाम्पल ये रहा जो हमने यहाँ पे किया, नंबर ऑफ हेड्स. ये काउंटेबल है ना कि नंबर ऑफ हेड्स विल बी 1, नंबर ऑफ हेड्स विल बी 2, नंबर ऑफ हेड्स विल बी 3. तो ये तो डिस्क्रीट रैंडम वेरिएबल हो गया. बट व्हाट अबाउट कंटिन्यूअस रैंडम वेरिएबल? कंटिन्यूअस रैंडम वेरिएबल का एग्जाम्पल ही वो है एनीथिंग विच इज कंटिन्यूअस इन नेचर. तो एक कंटिन्यूअस रैंडम वेरिएबल कैन बी समथिंग विच कैन बी ऑन कंटिन्यूअस बेसिस. जैसे फॉर एग्जाम्पल, इफ आई गो अहेड एंड टेल यू प्राइस ऑफ द कमोडिटी. हाँ, प्राइस तो डेसिमल्स में भी हो सकता है. जब हम डिमांड फंक्शन बनाते हैं, व्हेन वी मेक अ डिमांड फंक्शन, तो वी एज्यूम दैट प्राइस इज कंटिन्यूअस, है ना. प्राइस यूनिट 1 का भी हो सकता है, यूनिट 1.1 का भी हो सकता है, 1.2 का भी हो सकता है. सो फॉर ईच डिफरेंट क्वांटिटी वी एज्यूम अ फंक्शन. हम प्राइस को ऐसे लिखते हैं, P इज इक्वल टू से A माइनस बी क्यू. सो वी राइट इट इन द फॉर्म ऑफ अ कंटिन्यूअस फंक्शन. उस सेंस में प्राइस becomes continuous. Similarly, if I go ahead and I give you life of electric component, then also it is continuous variable. So discrete random variable हो जाता है when you are going ahead and calculating in discrete numbers. जैसे for example, number of children in a family. हाँ, ये discrete है nature में. It will be 0, 1, 2, 1.2 children तो नहीं हो सकते ना. You can't have a decimal there. So this is the difference between discrete and continuous random variable. Now, बेटा जो next चीज इसमें आती है, जैसे for example ये कुछ examples दिए हुए हैं, एक बारी just read it through. पहला example देखो, a page in a book can have at most 300 words. ठीक है, और x define किया गया है as number of misprints on the page. तो नंबर ऑफ मिसप्रिंट्स को हम काउंट कर सकते हैं, राइट. दैट ईदर द नंबर ऑफ मिसप्रिंट विल बी 1, नंबर ऑफ मिसप्रिंट विल बी 2, नंबर ऑफ मिसप्रिंट विल बी 3 एंड सो ऑन. ऐसा तो नहीं हो सकता दैट नंबर ऑफ मिसप्रिंट्स विल बी 1.4, 1.2. नहीं, या 1 वर्ड मिसप्रिंटेड होगा या 2 वर्ड्स मिसप्रिंटेड होंगे. सो वी नो दैट व्हेन वी टॉक अबाउट द नंबर ऑफ मिसप्रिंट्स, दे कैन नॉट बी इन डेसिमल. Either it will be 1 misprint or 2 misprint. You can't have decimals in it. So in that sense, it will become a discrete random variable because it will take finite values. वो fixed finite values ही लेगा. Similarly, like here it says x is reduction in the weight. Weight is a continuous random variable. Weight can be 100. It can be 100.01 kg. It can be 100.05 kg. It can be 100.50 kg. So weight can take infinite values, right? Don't go by the weighing machine, but you can keep breaking your weight छोटे parts में. Your weight can be between 100 to 101 के बीच में कोई भी value ले सकता है, right? So because the weight can take multiple values which are infinite in nature in a way, it will become a continuous random variable. इसको हम एक continuous random variable बोल देंगे. Now, बेटा let's talk about probability mass function. तो एक probability mass function basically it defines the probability associated with a random variable. जैसे अगर हम अपने एग्जाम्पल पे वापस आते हैं, then we know कि हमने x को लिया था as number of heads when 2 coins are tossed. ठीक है, तो we saw that number of heads can be 0, number of heads can be 1 and number of heads can be 2. ये तीनों ही तरीके के number of heads हो सकते हैं. Now just try to think about it that if I look into my sample space again, अगर मैं अपने sample space में देखूं, तो what will I find out? My sample space will look like this: HH, HT, TH, and TT. Right? इसमें से how many of them have 0 heads? I can clearly see that there is only one of this that has 0 heads. Out of how many? Out of total of 4. तो इसका probability will be 1/. Similarly, if I continue, how many of them have 1 head? कितनों में 1 head है? I can see that here I see 1 head and here I see 1 head. So there are 2 places out of 4 where I see 1 head each. So therefore, this will be 2/4. Now I need to see where I have two heads. तो बेटा यहाँ पर I can see two heads ना, here I can see two heads, only one of them, so this will be 1/4 and ये मेरा हो गया probability. So when we go ahead and when we give probability, जब हम हर x के association में, with association to each x, I am assigning some probability. When I give some probability, this is how we write the probability mass function. So like here I have written that px is equal to 1/4 when x is 0. It is 1/2 because 2/4 I was getting here, na? So 2/4 is 1/2 when x is 1, and it is going to be 1/4 when x will be 2. This will be my probability mass function. Now there are some properties of probability mass function. Each of the probability can only lie between 0 to 1. Of course, ये बात तो हमें पता ही है that probability cannot be negative, probability cannot exceed 1. So each of the probability that I have, जितनी भी हमारे पास probability होंगी, it has to be between 0 and 1. वो सिर्फ 0 से 1 के बीच में ही रहेंगी, right? Now, but the next thing that we need to understand here is that the sum of the probabilities will always be 1. हमेशा probabilities का sum 1 रहेगा, right? Now, this is exciting to see that if I go ahead and suppose मैं यहाँ पर I introduce something which is known as CDF. So beta, this CDF is cumulative distribution function. And by cumulative, I mean that I am going ahead and I am adding the probabilities together. So जब हम probabilities को add कर देते हैं एक साथ, what I get is called as the CDF. Now try to see here. If I go ahead and I start adding, so यहाँ पे this is the first one. So I will get the answer as 1/4. Then I start adding, so I will get 1/4 plus 2/4. So this will be 3/4. Then I continue adding. So I will get यहाँ से 1/4 plus 2/4 plus 1/4 equal to 1. This is giving me the CDF. So whenever we talk about CDF, जब भी हम CDF की बात करते हैं, CDF always implies that you need to go ahead and add all previous probabilities together. So this means that if I am writing CDF of x equal to 0, तो x 0 तक जितनी probabilities आनी है, whatever probabilities you are getting, you will add all of them. तो ये तो हो जाएगा सीधा, this is probability x equal to 0, which is 1/4. But if I go ahead and tell you that give me the CDF that x is 1, तो इसका मतलब ये होगा that I will go ahead and say probability x is 0 and probability x is 1. So this is 2/4 and 1/4. I'm adding these two values. So this will give me 3/4. Similarly, अगर मैं बोलूं CDF x is 2, तो बेटा this will be probability x is 0 plus x is 1 plus x is 2. तो यहाँ पे जब हमने सबको ऐड किया था, we were getting the answer as 1. अब यहाँ पर एक बहुत इंपॉर्टेंट पॉइंट है. Try to see that CDF will always increase. CDF हमेशा बढ़ेगा, कम नहीं हो सकता ना. I am adding more probabilities to get the next one. तो जब हम CDF 0 से 1 पे गए, when I moved from CDF 0 to CDF 1, I added additional probability. मैंने एक extra probability add की. So if I am adding an additional probability, I will get a bigger number ना. 1/4 is 0.25, 3/4 is 0.75. Similarly, when I go from x equal to 1 to x equal to 2, I am adding one extra here ना. यहाँ पे एक extra add हो गया. अभी तक 0, 1 था. Now I have added 2 also. So I am adding more and more probability. So it will keep giving me higher and higher number. And beta, at last, when I am finding at x equal to 2, जब मैं x equal to 2 पे निकालती हूँ, तो मैंने सारे पॉसिबल केसेस कंटेन कर लिए यहाँ पे. And we know that if we take all possible cases, then the sum should be 1. Because maximum probability will be 1 when I add all probabilities together. So at the last one, the CDF will become 1. It does not has to be a step function. It depends. Agar continuous variable hai, it can be, a continuous function also. I mean, if it is discrete, then it will be points. Like x equal to 1, I got probability 1/4. X has 2, I got half. X has 3, I got 3/1. So these are just dots, huh? But if it is continuous, then it could have been a function also. Like, for example, we have a typical normal distribution. So it depends. Not always it will be step function, but if it is discrete, then these will be dots. Okay. Now, the next thing, beta, is this. बहुत simple है that the sum of probabilities must always be 1. ठीक है. Now, कुछ examples देखते हैं. So try to see here. In this case, this will be in word, this got converted. This will be 2/4. This will be 1/4. Okay. Now just try to see here. Let me give you an example of the type of questions that will come in exam. Come to question number 2. Dhyan se dekho, huh? It is saying, given below is the probability distribution of X. Find out the value of K. So this is also incorrect. You should never say that CDF is increasing function of X. हमेशा बोलो CDF is non-decreasing function of X. ये मैंने ना, I think in mock paper I have given this question. So never say CDF is increasing function. कभी मत बोलना, हाँ? Just say CDF is non-decreasing. And there is a reason behind it. देखो, just try to see, beta. Suppose I tell you that X is a random variable. It can take values 0, 1, 2, and 3. And uska probability is given to you as 1/4, 1/4, 0, and 2/4. And यहाँ पे we need to find its CDF. हमें probabilities को add करना है. We need to add the probabilities. तो क्या होगा? Here it will be 1/4. Here it will be 1/4 plus 1/4, 2/4. Here it will be 1/4 plus 1/4 plus 0, 2/4. And here it will be 1/4 plus 1/4 plus 0 plus 2/4, 4/4, 1. So you see that when I moved from x equal to 1 to x equal to 2, जब मैं यहाँ से यहाँ move करती हूँ, the probability is not changing. It's not increasing, but it's not decreasing either. वो decrease भी नहीं की, right? So although it did not increase, but it did not decrease also, ना? So we can say that it is non-decreasing for sure. ये बोलना better रहेगा. Rather than saying it is increasing, bolo it is non-decreasing. So this is how you can go ahead and give the actual property. Okay. Now just take this question. So beta, this says find the value of K. Ab hamara kya property hai? This is a very common question in exam. We know that the sum of probability must be equal to 1. So if I start finding the sum of probability, I will get K plus 2K plus 4K plus 2K plus K equal to 0. So if you will add of all of these, you will get 10K, equal to 1. So if you add all of these together, you will get 10K equal to 1. So K will be 1/10. अब इसी में the examiner can change the question a bit. तो वो कभी-कभी क्या करेंगे ना? They will not say find K. ऐसा कुछ नहीं देंगे. They will give you this question and they will say find the probability that X is less than equal to 3. ठीक है? तो बेटा x less than equal to 3, तो ये वाला सारा values हो गया up to 3. तो x less than equal to 3 will be K plus 2K plus 4K plus 2K. So this will be 9K. And we have already found out that K ka value 1/10 hai. So this is going to be 9/10. So this will be 0.9. Right? So sometimes they may go ahead and they may give you a bit थोड़ा सा बदल के क्वेश्चन, दैट फाइंड द प्रोबेबिलिटी दैट x टेक्स वैल्यूज अप टू 3 और x at least takes the value 3 or more, ऐसा कुछ देंगे. So you need to go ahead and do this question accordingly. ठीक है.